Algebra 2, 3-3, optimization with linear programming. Oh, programming has two M's. Sorry. Optimization with linear programming. And what the idea is here is you have a couple variables, like in a factory where you're making tablets and cell phones or something like that, and you want to figure out what is the best way to optimize productivity and your expenses and overhead and all of that kind of stuff. You can use this process to figure out what is the best way or the best way to move forward in saving costs and time and all that kind of stuff. So we're just going to kind of learn how to do it, and we're not going to get too involved, but we're just going to get deep enough so that you can do it. So linear programming is a method for finding max and min values. And the feasible region, we're going to see the feasible region. This is the area that that we're going to use to help us find the max and min values. So are we going to even, what is the best way to say feasible region? Perhaps it's called the solution set, right? Okay, the feasible region is the solution set, yes, of course. And we're going to use that solution set to find where is the max and min, where are the max and min values. Okay, so you might have a system of equations that looks like this. And we'll have like 3 lines going this way, and these are your constraints. And this here is the feasible region. And we're going to look at 2 different types of feasible regions here, and one might look like this. All right, so notice how this one is enclosed and this one is not. And this one is called bounded, and this one is called unbounded. So this one doesn't have a minimum value, it goes on forever. Okay, let's do an example. We're just going to do a few examples, and then we're going to be done with this section. So our example here is find the max and the min for this system of equations here. So I've got 3 is less than or equal to y is less than or equal to 6. Y is less than or equal to 3x plus 12. Y is less than or equal to negative 2x plus 6. And then we have this f of x, y for 4x minus 2y. So when you get this equation down here at the bottom, this is the one we're going to use to plug in the vertices. Okay, now on the test, there might be one of these questions on the test, and you're going to need to find the vertices. So you're going to need to see where all of these cross each other in order to plug in the vertices at the end. I'm going to give you the vertices here. We'll graph it real quick, and then I'm going to give you the vertices without having to do all of the work because we already did that in 3-2, and we don't need to waste a whole lot of time doing that. But the first thing I want to do is I want to look at this mess right here. I've got 3 is less than or equal to y, and y is less than or equal to 6. So I need to break this up into 2 inequalities. One of them is y is greater than or equal to 3. See how y is less than or 3 is less than or equal to y, 3 is less than or equal to y, and then y is less than or equal to 6. I just need to break that up into these 2 different inequalities. So I'm going to graph this so I can see what's going on, and then we're going to do a table over here to plug in the vertices. So I'm going to make 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Okay, so y is greater than or equal to 3. So I'm going to find 3, 1, 2, 3. There is y equals 3 right there. And y is greater than 3, so I would shade up above here. Y is less than or equal to 6, so 3, 4, 5, 6, there is 6. And y is less than 6, so I'm going to shade underneath here. So those 2 are done. Now plus 12, oh man, plus 12 is going to go way up here. 6, 7, 8, 9, 10, 11, 12. And then I go up to, let's see, 3 over 1. So I go up 3 to the right 1. Or I can go down 3, 1, 2, 3, and to the left 1. 1, 2, 3, to the left 1. 1, 2, 3, to the left 1. All right, so that looks like that. It's not perfect, but it looks something like that. So I've got these 2 points of intersection here, those 2 vertices, and I'm shading y is less than this, so I'm shading underneath. I'm going to have some shape in here that everything works around, overlaps. Plus 6 is my y-intercept. So 1, 2, 3, 4, 5, 6. And then I go down 2 to the right 1, 1, 2 to the right 1, 1, 2 to the right 1. And so there is my other. And it's y is less than, so here is my feasible region. Right here is my feasible region. So now we're going to make a chart over here. We're going to have x and y. This is going to be where we put our vertices. And then we're going to have 4x minus 2y, which is this equation here. And then we're going to have f of x, y. This is what I get when I plug in x and y into this equation. So I've got 1, 2, 3, 4 vertices. 1, 2, 3, 4. Okay, so one of my vertices is 0, 6. That one right there, 0, 6. This one over here is negative 2, 6. Negative 2, 6. This one right here is negative 3, 3. And then this sad guy over here is 1.5, 3. So those are, so I might, if this was on a test, I might need to find each of these vertices. So it might be helpful to draw a really clean graph, and then you could, if you did, you could see that these 3 are all whole numbers here and easy to integers and easy to decipher. And then you would see that this one was not, and so you would just need to find the intersection of these 2 lines. Now, now I just need to plug in, this is my x value, this is my y value. So 4 times 0 minus 2 times 6. Plugging in x and y, I'm just going to fill out this whole thing. 4 times negative 2 minus 2 times 6. 4 times negative 3 minus 2 times 3. Just plugging in my vertices here. 4 times 1.5 times, minus 2 times 3. Okay. 0 minus 12 is negative 12. Negative 8 minus 12 is negative 20. Negative 12 minus 6 is negative 18. And 1.5, okay, so 4 times 1.5, 4 times 1.5 is 6. Minus 6 is 0. Okay, so that means, so now we just look at this and we say which one is the greatest. So 0 is the max here. And then which one is the least? This negative 20, so this is the minimum. And this is how this works. It might make sense to you, it might not, but this is how you do it. So we're going to do another one together, and then we're going to do one that's unbounded, and then we'll be all set. So this would be a U try, but if you want to do it on your own, that'd be great. Negative 2 is less than or equal to x is less than or equal to 6. 1 is less than or equal to y is less than or equal to 5. Y is less than or equal to x plus 3. All right, so it might be helpful to graph this, and then, oh, actually, if I'm going to give you the vertices, then we'll, can't really do it as a U-try. It's going to take forever for you to find the vertices. Not forever, but it might take a little while. Oh, and then f of x, y equals negative 5x plus 2y. So what we're going to do is we're going to break this up a little bit. So I'm going to do a U-try where you just graph this. Remember to break this up into 2 and break this up into 2. So go ahead and graph this as cleanly as you can. And then when you're done, we'll do that together, and then we'll fill in the chart part of it, and then you do the rest of the chart together as you're on your own, and then we'll check it together. Blah. So this is kind of a 2-step U-try. So graph this. Go. All right. Let's see how you did. So let's break this up into 2 inequalities. So one should be x is greater than or equal to negative 2, and the other one is x is less than or equal to 6. And then let's graph this one, or let's break this one up. Y is greater than or equal to 1, and y is less than or equal to 5. Okay, so I'm just going to graph these. X equals negative 2. I just go to negative 2, and I draw my line. And x is greater than, so I'm going to go this way. And then x equals 6. 1, 2, 3, 4, 5, 6. Draw a vertical line at x equals 6. And then x is less than, so I'm going to shade back this way. Now, y is 1, 2, 3. Okay, y equals 1 is right here. And y is greater than, so I'm shading up here. Now y equals 5. 1, 2, 3, 4, 5. Draw my line. Y is less than 5, so here I'm in this rectangle. Now I've got one more to do, x plus 3. So if I go up to 3, 1, 2, 3, there's my y-intercept. And then my slope is up 1 to the right 1. So, or down 1 to the left 1. Down 1 to the left 1. Down 1 to the left 1. Or over 1, up 1, over 1, up 1. Okay, so I can see here, I've done my graph fairly cleanly, so that means I can see all of my vertices. Now I have to decide, is this the triangle I'm looking at, or is this trapezoid kind of thing what I'm looking at? And so I need to look at this line, y is less than, all right, so that means that my feasible area, my feasible region, is here. So I've got 1, 2, 3, 4 vertices to look at. So let's start our chart. And we are going to have x, y here. We're going to have this equation, or this expression here, negative 5x plus 2y. And then we are going to have our f of x, y here. Okay, let's keep moving. So we are going to have 4 vertices. And one of them is going to be right here, and that is negative 2, 1. So I've drawn this well enough that I can see where these vertices are. This one here is 1, 2, 1, 2, 3, 4, 5. 2, 5. And then I've got these two over here, and they are 1, 2, 3, 4, 5, 6. They both have 6 as my x value. And then 1 is my y value here, and then up here this was 5. 1, 2, 3, 4, 5. And so those are all of my vertices. Now follow this example here and find my max and my min values over here. And pause and go. All right, let's see how you did. I'm just plugging in my x and my y. Negative 5, x is 2 plus 2 times 5. Negative 5, 6 plus 2 is times 5. Negative 5 times 6 plus 2 times 1. Okay. Negative 5 times negative 2 is positive 10. 10 plus 2 is 12. Negative 5 times 2 is negative 10. Negative 10 plus, this is a 5 here, plus 5 is 0. 10 plus, negative 10 plus positive 10 is 0. This is a 5 here as well. Negative 5 times 6 is negative 30, plus 10 is negative 20. And then my last one here is negative 30 plus 2, which is going to give me a negative 28. So now I have to see which is the greatest, and that would be 12. That is my max. And then the least is negative 28. That is my minimum. And that is how we do that. Now let's look at an unbounded example. And let's see. Let's do this one. X is less than or equal to 5. Y is less than or equal to 4. X plus y is greater than or equal to 2. And f of x, y equals 3x minus 2y. Okay, so let's graph this, and we'll see if it's bounded or unbounded. And so we go x 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There's my x is equals 5, and x is less than 5, so I'm going to go shade this direction. Y equals 4, 1, 2, 3, 4 is here. And these are all, or equals to, so it's including that line. Y is less than 4, so I'm going to shade underneath. And then x plus y is greater than or equal to 2. I'm going to subtract 1 from each side, subtract x from each side, so I get y is greater than or equal to negative x plus 2. So I find where 2 is, 1, 2 is right there, and then I go down 1 to the left, down 1 to the right 1, because it's the slope is negative 1 over 1. Down 1 to the right 1. Down 1 to the right 1, down 1 to the right 1. And I'm going to try to be super clean with this. Up 1 to the left 1, up 1 to the left 1. So I'm over 2 here. And then, oh, this one's not unbounded, is it? Oh, gosh. Well, oh well. 1 down 2, down 1, down 2. And then y is greater than this. There's my shaded, there's my feasible region. This is not unbounded, this is bounded. I thought I had a good unbounded example. I think I'm going to come back with a bounded example. So, but you can finish this one out. Find these 3 points, and then do your chart. And so you can go ahead and do that, and I'll come back in the next video with an unbounded example.